This lesson looks at quadratic inequalities in one variable, and this is section 9.2 of McGraw-Hill-Ryerson Pre-Calculus 11. At the end of this lesson, these are the 3 things that we expect students to be able to do. I strongly encourage you to interact with the video, pause, rewind, do the questions, check in with the video for the answers, so an interactive role to enhance your learning. We're going to specifically cover outcome RF8, and when we do that, we also have to tap into information that we knew for RF3, RF4, and RF5. That's chapter 3 and chapter 4. We need to be able to graph a quadratic. We need to be able to solve a quadratic. There's multiple ways to do these questions. I want to show you both ways, so it does seem to get a little bit, what's the word I'm looking for, cluttered on the screen, but we're going to try to do 2 methods so that you can see the 2 ways to do the question. You do not have to demonstrate both methods, you just need to be able to get to that answer. So demonstrate it in one way. When we're looking at this, we have a quadratic. It is saying to solve. This is looking different than what we had in section 9.1 in a couple of ways. The first way you might notice is that this is quadratic and not linear. So we know that we have a parabola. The second is that this only has one variable. So 9.1 and 9.3, those 2 lessons are dealing with 2 variables. They have x and they have y. This one only has an x variable. That's why we say that it is a quadratic inequality in one variable. That means that we're looking at number line. So our answers are going to look very similar to what you may have done in grade 9. Where are we going to start? Well, when I see the word solve and I have a quadratic, I think chapter 4. I think find my zeros. What are the roots? So we can graph it. We can factor. We can use completing the square. We could use the quadratic formula. Whichever method is the easiest, but you need to start by finding the zeros. So this is set up very nicely for factoring. So use this function, or we're going to use this equation. We want to find the 0. So we factor x minus 3, x plus 1 equals 0. So x is equal to 3, or x is equal to negative 1. So these are my zeros. These are the points that are crossing my x-axis. That's really important. Let's graph that, because this is going to give us some information, some valuable information. That's why we've looked at the zeros. Now I put solid dots in. So let's go back to our original statement and make sure that we're okay with that. Right here, it says less than or equal to, so we know that solid dots, that's good, because that's the or equal to, so we're okay with solid dots. What does this parabola look like? Well, there's a few things, or different ways, I guess, in which you can do this. You can use the vertex, find table of values, use your zeros, write table of values. You can use PQ formula. You want to have a sketch of this graph. Now, we only need a sketch. We don't need to be perfect, but let's just recap some of that information because it's going to help us. We can tell right from the graph that we have an axis of symmetry right here. So our axis of symmetry is at x is equal to 1. What does that tell us? Well, that tells us our p-value. So we know that p is 1. Now, I don't memorize my q value. What I do is I substitute my p into my equation. So I put this equation, and I substitute the value of p into it, and I get negative 4. That tells me my q is at negative 4. So this is my vertex. My vertex is the point 1, negative 4. Gave me a lot of information just by that graph. The zeros, led me to here. You can complete the square and you can find the vertex, but really all we need to do is have a sketch. So we know also it does open up. We know that because our leading coefficient on the x squared is positive, or you could even use the fact that it's a 1 and transformations to know what the shape is. So there, as you can see, the information you know from 3 and from 4 all meld together so you can figure out how to graph this. Well, now that we have it graphed, let's go back to the original equation. It's wanting us to solve an inequality. And we're wanting to know where is the parabola less than 0. That's really kind of what we're reading. The parabola less than or equal to 0. I'm going to use the highlighter to shade so you know where we're looking. It's asking us this question: where is our parabola in this region? Well, it's in this region for any value of x between these two numbers. All right, so if I have a value of x at -2, is a corresponding y point here. If I have an x value 0, corresponding y value. And all of these are going to correspond to y value that is less than or equal to the 0. So I can write a mathematical statement to represent that. And I can say that -1 is less than or equal to x, which is less than or equal to 3. And that's describing this region that I'm doing here in red. Now we're used to seeing this on a number line in grade 9. So we'll just look at what that looks like on the number line. We already know this answer. All right, so we had said that our answer was this. Okay, that's what that answer looks like in the number line. Now I'm going to show you another method using the number line to get to that answer. When I do that, I want you to think about this polynomial is being x squared minus 2x minus 3. Now, the p of x in this case just representing polynomial of x, whatever polynomial it is. I know my zeros, so we did our zeros before on the previous page. So we always start with our zeros, and we said that our zeros were at -1 and at 3. I always start with putting a hollow dot in, and then I go back to my question and I check, is it hollow or is it solid? And it's solid because it's an or equal to. This method I'm going to show you is one that translates into powers of 3, powers of 4, powers of 5, and so on. So it's very powerful. It might be a little overkill concept when we're looking at quadratics, but at least if you follow through this, that when you address these types of questions in grade 12, then you have seen this method that can help you with it. What we're going to do is take where the zeros are, basically divide our number line into regions. And I want to pick a value that is in, let's start with this region. Just pick a number from our number line that's in that region, and I'm picking 4, -4. Okay, so we're looking at -4. And I want to know the value of the polynomial at -4. But all I really care about is it positive or is it negative? So what I'm going to do is put -4 into my polynomial. So I have -4 squared minus 2 times -4 minus 3. And I just want to know, is that a positive value or a negative value? So that's 16 plus 8 minus 3. That's positive. I don't even care what the number is. So this region is positive, the entire region. Well, let's look at number this region. I like 0. Whenever I can, I always take a 0 because it makes my calculations very easy. So this is giving me 0 minus 3, right? 0 squared minus 2 times 0 minus 3, that's negative. So any value between -1 and 3 is going to return a negative. So very similar to what we've already done. Let's pick a number in this region. Let's pick 5. So in this polynomial, I put in the value 5. Then I have 5 squared minus 2 times 5 minus 3. 25 minus 13 is positive. So this region is positive. I'm going back to my statement where I have my quadratic, the positive quadratic that I have right here. This is the one I was using. Now I know my inequality is saying where is it less than or equal to 0? So where is that negative? And here is the negative region. Oops, the wrong pen. And this is what my inequality would look like. There's my number line, which is what we saw before. And my inequality statement, -1 is less than or equal to x, which is less than or equal to 3. What does that final answer look like? It looks like one of these things. It looks like this, or it looks like my number line. I'll erase everything else that we've done right there. It looks like what we have here for our number line. You may really need to go back over certain sections here to have that sink in. Let's try another example. Now this one I need to give you a little bit of guidance on, and then I'm going to get you to go from there. I want you to notice a couple of things. First thing to notice, this is not equal to 0. We have our quadratic, and we have this set up so it's less than -12. Take your parabola, or look at your function, your inequality in this case, and you want to have all your variables and constants to one side, the left-hand side. The reason for that is that we can read this statement. We are used to reading it, so it says the parabola is less than 0. If you read it the other way, 0 is greater than that parabola. That makes it a little bit harder for us to understand. The second thing, so we've done this first, the second thing is we have a negative that we're leading with. And that just makes it a little harder for us for factoring. Now you can do it that way and leave it and get the exact same answer. Okay, so you can use this for your number line right there. You can use quadratic formula, find your zeros. I just find that harder, especially if I'm going to be factoring. So what I'm doing is I'm rearranging the equation so that I have a positive x squared. When I'm doing that, basically I am multiplying by -1. When I do that, I get x squared minus x minus 12. And what happens with my inequality? My inequality switches. This is now my equation that I'm working with. It's not my original. It's my original been tweaked. Right, so I've rearranged it. It is mathematically equivalent, but it looks different. So this is now my new equation that I'm going to work with. So if you want to start there, try that on your own, very similar to what we did with our introductory example. When we left off, we had set up our equation, so we had our parabola x squared minus x plus 12 is greater than 0. So this is now our new inequality that we're going to be looking at. You found your zeros, so it was x minus 4, x plus 3 are the factors. So x is equal to 4, or x is equal to -3. I'm going to solve this by graphing first. So when I do that, my roots I'm actually going to put a hollow dot in just to give me that visual that this is not an or equal to. It is a parabola that opens up. So on a rough sketch, I have something like this. I'm not really worrying about the vertex. Because I'm looking at this statement that's in red, this is my inequality, so it is looking at greater than. So visually, we are wanting to know where is the parabola in this region, and we can tell that it's in this region here and here. The inequality statements that would go with that would be that x is less than -3, or where x is greater than +4. That is where this parabola is greater than 0. So here is my inequality statement, the answer. What does this look like if I'm using the number line to help me? Well, the same thing goes as before. We had x squared negative x plus 12 equals 0, so my zeros are what I'm looking for. So we have x is equal to 4, where x is equal to -3. So we pull out our number line. We are looking at these as the zeros. Looking at these three regions, I'm going to pick a value for all of them. And remember, my polynomial that I'm looking at is x squared minus x plus 12. Let's pick p of -5, p of 0, p of 5. We can't have it where the 0 is. It can't be on the root. Put these values into this function. So we've got -5 squared, right, minus a -5, which is +5, plus 12. So that is positive. 25 plus 5 plus 12. This region is positive. We do p of 0, and we get 0 minus 0 plus 12. For those of you that have been paying attention, you probably realize that I made a mistake and I just caught it now. It really helps if I teach in front of a class so you can tell me as soon as I make the mistake. Copied this down wrong. That should be a negative. Our roots are right because I just took it from there. So this should have been -12. So the roots are right. My problem with my problem that we have here. And I realized that, so sorry for this mistake. We caught it really good. Okay, so it doesn't affect the p of -5. This is going to return a positive value, but it does affect the 0. And that's when I realized there was a problem. And if you realize why I knew that is because I know in this area it had to be negative, because we just did this question with the graph. So this region is negative. So sometimes we make mistakes, and when we see them, we have to realize something doesn't make sense. So the more you know about what's going on with the parabola, then the easier it is to understand when you make a mistake. And then we fix it. I'm picking p of 5, and that's going to also return a positive. So this is going to be subtracting 5, subtract 12, but that's still positive. Now, The question we're looking for, we have to go back to what that first inequality statement was. And we changed it, right? So we said this one that's in red, oh, look at that. That's where I made the mistake right there too. Must have been when I recopied it. Okay. That's the one we're looking as our original statement. We've taken it from there. So this was greater than 0. There's my original statement. So where are these positive? Positive here. And it's positive here. So this blue gives me my number line. My inequality statement would be where x is less than -3, or any value where x is greater than 4. Sorry about that mistake. That's a little rough, so maybe when we do another question, it'll make it a little bit smoother. Here's another one. Remember what I said, we want to have all of our variables on one side of the equation, preferably on the left of our inequality, with a positive x squared. We want you to try that, and then I'll be modeling this. So for my sake, I just find I had the x squared is already on the right, so I'm just going to write my statement like this. But I said it helps if it is on the left, because this is saying 0 is greater than this polynomial. But if I read it from right to left, it says the polynomial is less than 0. So here's where you need to be careful about your signs and your inequality. That these two lines are saying the exact same thing. Be aware of that. Okay. Another way is that you could have made sure everything was on the left-hand side, and then you had to do a sign change and then switch your inequality. So you should end up with the exact same thing, no matter which method you used. I need to find my zeros. That's the next thing we need to do. Yeah, that doesn't look so nice, does it? To find the zeros, because it's not an x squared. So factoring isn't as easy, but can we factor? If we can't, then let's go to the quadratic formula. But I'm asking myself what multiplies to give me -18 and adds to give me -3, -6, and +3. So this one is factorable. Grade 10, we talked about it as a long trinomial. So I'll just model this right now. I'm using the decomposition method. It's the one that I use the most often. And I'm showing all my steps, so if you remember, it might help you to recall how to do this. And really, what is this asking of us? I'm doing this procedure to find out where my zeros are. So where does this equal to 0? And so that's saying where x is equal to 3, or where x is equal to -3/2. That is where my zeros are. Oh, it's going to grab everything. Let me see if I can do it so I don't grab everything. Okay. So I made that a little bit smaller. Let's pull in the graph. From the graph, this is telling me, of course, where my zeros are. It is a less than, not an or equal to, so I'm going to use hollow dots at 3 and at -1.5. Again, really not having to worry about exactly where that is. I know that this is a parabola that opens up. So technically, this is what the sketch would be. It's not a real technical drawing, though. It doesn't have my vertex and it doesn't have other points. It's just a sketch. And I want to know, where is this less than 0? So where is it less than 0? It's less than 0 in this area. My number line is going to be right in here. So this is saying that at -3/2 is less than x, which is less than 3. That would be my answer. How does that look when we do with the number line? Oh, let me just take this, I'll just clone this page. And we said that our zeros, just a reminder of where our zeros are, 3 and at -3/2. Because it was set up so it was a less than 0. Was it? I'll double check. You don't want me to make that mistake again. So 2x squared minus 3x minus 9. And we said, where is that less than 0? And we take these points. We're going to find a value for x in each region. So let's take p of -2, take p of 0, and I'll take p of 4. So my polynomial 2x squared minus 3x minus 9. So p of -2 is giving me 2 times 4 minus 3 times -2 minus 9. So 8 plus 6 minus 9, that's positive. Take p of 0. So that's giving me 0 minus a 0 minus 9. That region is negative. If I take p of 4, that's 2 times 4 squared, which is 16, minus 3 times 4 minus 9. It's still just going to give me here a positive value. My statement that I have here is asking where is it less than 0, and it is less than 0 in this region. So there's my number line. My inequality statement is this one. Again, another way to get the answer. Try example 4 so that you can get this set up. See what that would look like. Well, if you were to factor this, you'd realize, well, I can't factor it. So there is no number that multiplies give me 7, but adds give me 5. So there's a couple of strategies that you can have here for your zeros. One is, are these zeros rational, irrational, or are there no zeros? So if you think back to chapter 4, there was something called a discriminant. The discriminant could tell you if you had non-real roots. So if I did my discriminant, which is b squared minus 4ac, and do a real quick check, that might give me some information without having to do the entire quadratic formula, but you can use the entire quadratic formula. When I do this, I get 25 minus 4 times 1 times 7, and that's 25 minus 28, which is -3. Remember, this is my discriminant. That tells me that there are no real roots. So what does that look like? Well, I can find my axis of symmetry and find out what that information is. I can use a table of values to determine. Right, so now I want to know really what does it look like. Let's go to a table of values. When I put in a value for 0, x is 0, that's my y-intercept. I know that that is 7 just from my equation. And if I put in a 1, I'm just going to get larger. So let's put in -1. I put -1 in, and I get 1 minus 5 plus 7, 3. I put in a -2, and I get 4 minus 10 plus 7, and that gives me a 1. And I put in -3, and I get a 1. Oh, right away, I know where my vertex is. I know where the p-value is going to be between -2 and -3. So -2.5. And I got my -4 then is at 3, and -5 is at 7. So using that table of values, I even know exactly what this parabola is going to look like. Okay, taking the information that I have and plotting this on my graph helps just to give me what the shape is and what it looks like. So -2, 1, -3, 1. The vertex is really going to be about there. We had already determined there were no real roots. What does that mean to us graphically? It doesn't cross the x-axis. When my discriminant is negative, I have no real roots. It means the parabola does not cross the x-axis. Okay, so here is our graph. Let's look at our statement. And it's asking, where is this parabola greater than 0? Well, here's the 0 line. Where is it greater than 0? Everywhere. The entire thing is in the greater than 0 region. So what does that mean for my number line? Well, for my number line, oh, I can actually pull in my number line. It means that every point is on the number line. Oh, I'm having trouble grabbing the number line here. So I just ask, what does that mean for my number line? It means the entire number line is my answer. It's everywhere. No matter what value of x I have, the value of y is going to be greater than 0. How do I write this as a mathematical statement? Every value of x. So x belongs to the set of all real numbers. That's what that's telling me. X is all reals. Okay, we're going to take this same question and we're going to just do one little flip. What did I do? I changed the inequality. So again, here's where a graph comes into play. It makes this easy for us to, I'm just going to sketch here though. Looks something like this. This question is asking, where is it less than 0? Where is it in this region? It's not in that region anywhere. So what's my number line going to look like? Oh, same problem here. So what does that number line look like? That number line's blank because there is no answer that's there. And what we have is that there is no solution. There are no real roots, but the no real roots doesn't necessarily mean that there's no solution. No real roots is just telling me that this does not cross my x-axis. And as we saw in the previous example, when it was a greater than, everything was an answer. Here, because it's less than, and there's no area that's less than, this is our less than region, our answer is no solution. Okay, let's go backwards. Here's the graph. What's the inequality statement? We just want to find the solution from the graph. So this is really simple in comparison to what we've been doing. Well, if we want to think about this as our function, where is it less than 0? And it's open. There's my zeros. And it's less than here. So it's -8 less than x less than 7. That's all we're looking for, just that statement. Okay, we have 3 other examples, and these are also ones that are thinking backwards, where I'm giving you a type of solution and I'm asking you to give me a quadratic inequality that fits. There are more than one answer. So there are multiple correct answers. When I go to do these myself, I'm usually dealing with an A value of 1 because that just makes them simple. Take a moment, see if you can come up with a solution or a drawing or a graph, depending on what you have. Can you come up with a quadratic inequality that fits? Well, let's look at A. If I want to start with this, my zeros are going to help me, right? So my zeros are x is equal to -2, x is equal to 4. Converting that into quadratic, that would be x plus 2 times an x minus 4. In this particular case, we're going to say, well, where are they greater than 0? So if this is a parabola, I'm thinking about the parabola kind of doing this. Okay. Where is it greater than 0? Why is it not greater than or equal to? Because I do have hollow dots here. So if we look at this, I have hollow dots. This is perfectly correct. If you wanted to expand it out, you would have x squared minus 2x minus 8 greater than 0. That's one answer. Other answers have -2 and 4 as the roots, as our zeros. Well, what's a no solution? What could you have had for no solution? Well, there's a couple of variety ones. We just saw a no solution where we had a problem that opened up, and the no solution is where was this function less than 0? So something like that. You could have asked the question, you had the parabola that opened down and you want to know where was this function greater than or equal to 0 even works. We could have the equal to on this one. So there's 2. Have a lot of room there. We'll move this one in. I could have one that has my vertex on the x-axis, which is right there. But when I do something like that, I want to know where is it less than 0? I cannot put the or equal to in. So that one definitely has to be a strict less than or greater than. Okay, so an equation like those. So if we had to write something that worked, can you get to an equation with that? Well, this one, it opens up. I have, maybe it's x plus 4 squared plus 1. Where is that less than or equal to 0? That type of an equation works. This one could be x plus 4 squared minus 1. Where is that greater than or equal to 0? This one could be x plus 4 squared. And where is that just strictly less than 0? So those are some equations. So you can see that there's multiple correct answers, an infinite number of answers. Our last one is written as an inequality, or sorry, as this statement. These are how they're written in your textbook. So when it comes to assessment time, if we were to have to select an answer, they would be in this form because they meet up with your textbook. So I was perhaps a little sloppier early on. They're still correct, it's just a different form. Really, this is what we're looking for. And what does that look like on my number line? Looks like that. All right, shade this area in. My zeros, it says x is equal to 0, x is equal to -4. So this is giving me x times x plus 4. Where is this less than or equal to 0? So x squared plus 4x less than or equal to 0. That's one correct answer. So this lesson was a lot longer than I was anticipating, so hopefully you've paused throughout and have done some of these questions. Here are some for you to use or to do that are in the textbook. Notice that these questions, I just picked one of each of them, and it actually tells you to use a specific method. Use any method. It doesn't matter which method you want to use.